Hello, everyone. This is Cameron Smith from TechLogix here today to go through another 15 to 20 minutes worth of fiber optic topics. This morning, we'll be talking all about fiber optic connectors. This is part of a larger course that we offer. Several folks on the call may have taken that before. We like to teach a lot about fiber and a lot about technology here at TechLogix. You might know that some of our sessions count towards CEDIA and Bixby credit. And if you are interested in receiving certifications for some of the different things that we do here, feel free to email us. You'll see contact information at the end of the webinar. We're happy to get you certificates, get you course code information, and get you moving forward with some of the renewal units that are offered as part of these classes. One thing I will mention, this session is being recorded. You will receive a link after the session to the recording. Feel free to share that with folks. Also, everyone is muted today. We get a lot of people on these calls, these webinars, and if you do have questions, those are perfectly okay. Please type those into the GoToWebinar widget. We will answer those either at the end of the session or we'll engage you one-on-one depending on the complexity of the question. Now, without further ado, let's talk about connectors. But before we actually get into the heart of the conversation, let's make sure we cover a little bit of information. First, there are some considerations when choosing fiber optic connectors. A lot of people think a connector is a connector, and while they have similar performance, while they have similar function, there are some things you need to keep in mind. First of all, fiber connectors are specific to the type of fiber cabling you're using. We'll talk about the cabling here in a minute, but there really are two different types, single mode fiber and multi-mode fiber. You need to make sure that you're terminating and selecting connectors that are made for the fiber you're using. So if you've got single mode fiber, put single mode connectors on there. If you've got multi-mode fiber, put multi-mode connectors on there. The core size, the glass inside those cables, they're really different. So you got to make sure the optical lenses in those connectors are proper for the type of cable you're using. Now, the other thing that you should mention is so much of the connector conversation has to do with style, the form factor of those actual connectors, not so much the performance. A lot of people will ask us, well, do I get better performance out of an LC connector or an SC style connector? Which one's going to operate the best? They all have the same optical lenses, at least in terms of overall bandwidth and overall performance. So it really comes down to what devices are you connecting to the fiber? That should help determine the type of connector that you operate with. Now, before we talk about those specific form factors, let's make sure you understand the fiber itself, because there are two different types that we encounter in the fiber optic world. The first is single mode, okay? If you've ever seen a yellow fiber optic cable, that would be a single mode fiber optic cable. The aqua colored ones, maybe the orange colored ones if it's an older cable, that's multi-mode fiber. And the difference again is the core size. Single mode has a smaller core. And this is a little counterintuitive to a lot of folks who have been doing low voltage and AV installations for a long time, because a smaller core typically means a shorter distance. Well, in the fiber world, that's not how it works. In fact, a smaller core size, so a single mode fiber optic core, which is 9 microns. I mean, we're talking the diameter of a human hair here. That's the cable that we can go very long distances with. That's the one that we connect buildings with, cities with, continents with. Single mode fiber goes long distances. Multi-mode fiber has a 50 micron core. That's the thicker one. 9 micron versus 50 micron. And that one maxes out at about 1,000 feet. So we see a marked difference in terms of diameter and in terms of distance, single mode going miles, multi-mode going short distances. The difference in that core size really lends us to using different types of connectors. Now, that cable will also come in grades. So if you have a single mode cable, you will see OS1 or OS2 certifications on the jacket typically. Most of us manufacturers, we use OS2 now. Good news is the core size is the same, 9 microns, in both OS1 and OS2. So you can splice it together, you can share connectors, you can use couplers, things like that. Multimode is where you run into an issue. Multimode, you have OM1, which is a very old and what we would consider today a non-standard, non-typical type of fiber. It's not only not optimized for modern electronics, but it's a 62.5 micron core. So you have to have a connector made for OM1 multimode. It's the only sized core, or the only core sized glass out there that will fit with an OM1 connector. It's very specialized. It's been discontinued by most manufacturers. At the minimum, you want to think about OM2, OM3, OM4. We're even seeing some OM5 in some enterprise networking applications. But really the go-to here, OM3 and OM4. Both are 50 micron cables, both handle 10 gig, both handle the on-net depending on your electronics. Couple of other things you may be noticing. There's some color coding that's standard to fiber optics. You see that here on the slide. I'm happy to send these slides to anybody who wants them. Again, you'll see our contact information at the end of the session, or go ahead and type the request into the question section in the GoToWebinar software. We'll get you the slide deck. Now we can turn our attention to the actual connectors. And again, as I mentioned, these tend to be color coded. We use a lot of standards in the fiber optic world. There are six. There are six main connector styles that you will see. Again, they have similar performance. It really comes down to the physical dimensions, the physical size and form factor of these connectors. Here's the good news. In the AV industry, we really operate with two, LC connectors and SC style connectors. But depending on your installation, your application, the age of the install, if it's a retrofit, you might encounter some different styles. Let's talk about those common ones first. LC style connectors. LC stands for lucent style. This is the small one. A lot of people call it the little connector. Makes sense because it's the small one. This is the connector you see on networking switches. SFP module, so the actual fiber module that goes inside the switch. A lot of manufacturers, TechLogix included, we use the LC connector on our AV over fiber extenders, like HDMI extenders. We use this one because it's small. It allows us to make the boards of the electronics smaller and make a smaller physical footprint. And it acts very, very well. It clicks into that port, it stays in that port. It's a well-built, well-designed connector. It costs a little bit more to manufacture and to implement. Lucent has a patent on this, but this is the predominant connector that you'll see in most applications. Now, if you're wiring a DMARC, or maybe you're working on a telecom application, you may see a bigger style, an SC style connector. This one is a little bit larger, costs a little bit less because you're not dealing with a patent. SC stands for subscriber connector. Some people call it the standard size connector. This is where we're going into couplers, multiplexers. That DMARC box will often have this, and some older networking equipment as well. Now, LC and SC style connectors terminate in the same manner. So this is something you want to keep in mind, and we'll talk about this here in a minute. What tools do you use? What's the process that you use? Well, the good news is if you can terminate an LC, you can terminate an SC, and vice versa. The same process, the same tools really hold true. These tend to be universal style connectors. They're pretty easy. Takes you about a minute to a minute and a half, depending on the type of cable that you're using. We'll talk more about that, but let's get through our connectors first. So ST style connectors. This one stands for the straight tip connector. I personally like ST connectors. They remind me of the BNC style that we used on the video equipment for years. Don't use so many BNC connectors anymore, but they were nice because they physically locked the cable into the port, and an ST style connector operates in much the same way. We see this one in some older networking applications, some older datacom applications. It's also quite similar to the FC style connector, the ferrule core connector. This is another locking style, kind of a barrel style. This one we don't tend to see as much in datacom and networking applications. the FC style connector really found its role in test equipment and some broadcast equipment like video over fiber electronics that are used for SDI and some other broadcast standards. It was nice because you could lock it into that port. Again, it wouldn't pull out, but it cost a little bit more. It was a very specialized connector. You just don't see it as much anymore. Now we get into the really specialized connectors. MTRJ, this one's known as the Mechanical Transfer Registered Jack connector, quite a mouthful, right? This is basically only used for multi-mode type fiber. So if you remember back to the beginning when we were talking about cable, that aqua color cable, that's a multi-mode cable. That's what would implement an MTRJ connector. And this was really designed specifically for networking, specifically for high density connections where I'd have one jack that could have multiple pieces of fiber and I could have a really small footprint. Now, finally, the sixth one we'll talk about, the FJ style connector, very specialized. In fact, so specialized that only one manufacturer uses it, Panduit. This one stands for fiber jack connector, and it was designed specifically by Panduit to wire buildings. The concept here was, hey, if we have a plug and play, quick connect connector, you know, we're going to standardize our installations and all of those building wiring components with this one type of connection. If you use Panduit, it's great. If you try to implement something else, you're going to have a hard time. So this is a legitimate style connector. It's out there. It's part of the dialogue. Those are the six main types of connectors that you see in common practice. There's some very specialized connection formats as well out there, but these are the ones that you might come up against. Now, we also have to talk about how you put those connectors on the cable. And before we look at a couple of diagrams here, let's make sure you understand the three predominant connector styles, at least in terms of termination and securely mounting these connectors onto the cable. We really do three different things, three different processes to put those connectors on the cable. The first is fusion splice, and you might have heard of fusion splicing cables and connectors and things like that. Fusion splicing is where we actually melt the glass, we fuse it together. Two pieces of glass get fused together, and often in a fusion splice environment, you'll buy not raw connectors, but a pigtail. This is where you've got a cable whip, maybe it's got two pieces of glass and connectors, six pieces of glass and connectors, but they're pre-terminated, they're pre-mounted. And we take the trunk cable and fuse it, physically melt it to our bulk cable or our trunk cable and our little pigtail whip. Now, the good news here is you have some of the lowest amount of dB loss out there. This is a very reliable way to terminate, but it's a very hands-on, expensive way to terminate because the equipment used in fusion splicing costs a fair amount in most cases. The other nut thing is you don't have reusable connectors, so it's kind of a one and done process. But if you're doing really high-end broadcast, if you're worried about loss on your runs, you might want to consider fusion splicing your connectors. Mechanical connectors operate a little differently. These have more moving components to the connector, so they might cost a little bit more, but the tools are a lot less. They terminate very, very quickly. Mechanical connectors are what we see typically in the AV industry. They do have a little bit more dB loss. So for example, a fusion splice connector might have 0.1 dB, whereas a mechanical connector is going to be 0.2 to 0.3 dB, pretty standard. They're not quite as strong once you put them on the cable, but look, $500 worth of tools, you're in the fiber business, you're working with mechanical connectors. We see them quite a bit. And that 0.3 dB or 0.2 dB of loss that you get out of a mechanical connector, that's well within what we would call the link budget, meaning the amount of loss that you can have on a system. In fact, you can put a lot of mechanical connectors together in a run of cable, and you're going to be in good shape. Okay, so 2 or 3 different ways we approach putting these connectors onto that cable, there's pros and cons to each way. Now, the process to terminate is largely the same depending on the connectors, as I mentioned before. However, the cable, the type of fiber optic cable you have, will dictate different processes. What do I mean by that? So there's really two types of cable that you'll use, the optical cores inside the cable more specifically. You will have polymer cables, polymer-based glass. It's really hard to fusion splice it. It's fairly specialized, but if you're using a mechanical connector, it's great. Terminates quickly, incredibly robust cable. Literally, you can tie it in knots, it won't break. It's a good way to broach the termination topic. Now, there's also bend-insensitive glass. This tends to be much more common, especially when you look outside the AV industry. Companies like Corning, most people know Corning, they make bend-insensitive glass. It gets incorporated into a lot of cables. It's a slightly different process, but you use the same connectors and the same tools, regardless whether you have a polymer-based cable or a glass-based cable. My advice to you, watch some videos. There's great videos online. They'll walk you through this process. They take 3 to 5 minutes, and it's really a step-by-step thing. So you can see the different pros and cons to the termination. But again, the tools are universal. The connectors are universal. A couple final things that I want to mention. If you do have questions, start thinking about those and typing those in now. But with the connectors, we also see couplers and adapters. A coupler is what's going to take two of the same type of termination, two of the same type of connectors, and splice them together. It's going to couple them together. And, you know, usually a coupler is going to have female ports on both sides. You get an LC to LC, an SC to SC, et cetera, et cetera. So these work pretty easily, and often you'll find these couplers in wall plate keystones or maybe panel mount patch panels and things like that. But then you can also get adapters. So an adapter is going to take one style of connector and convert it to a different style. You see a lot of adapters being used to bridge retrofit applications. So for example, I may have pulled my cable 10 years ago. I put ST style connectors on it, but I want to go into a modern network switch. So I need to convert that ST style to an LC style. And yes, you can get patch cords that do that, but you can also get adapters. Now, the final thing that we'll mention here, there are enclosures. Enclosures do implement couplers. They do implement adapters. You'll see rack tray enclosures. These are not only great for coupling and patching our different connectors and cables together, but they're a good idea because they also manage your cable. You have service loops. You have bend radiuses inside of here. It really manages all of those fiber optic strands. And fiber enclosures, if you've never taken one of our other trainings before, fiber enclosures are designed specifically for fiber optics. These are not universal. This is not the same thing that you're going to see in twisted pair. They're also not that expensive, but it is important to get an enclosure that's specifically designed for fiber, whether it's a rack tray or whether it's a wall box. Wall box enclosures, D-Mark and boxers, they have the same components, right? They have coilers inside. They manage a service loop. They create those splice points. They can adapt and couple those cables, those terminations, those connection types for you. So with that, I want to thank everybody for attending. You know, we spent about 20 minutes here going through the different connectors. If this is the first time you're seeing fiber optics, great, welcome. There's a lot of good information online around this topic. If you have taken some of our other classes, thank you again for spending some time with us. You see the contact information on the screen. So if you do have more information here, feel free to email us at info@tlnetworks.com or call us, call the office, 608-960-7242. We're happy to talk through any of these topics here. We're happy to, you know, help point you in some different directions to get you some more information. And I also want to encourage you to take some other training classes. We have several modules online. It's a lot of good information. Now's a good time to learn, especially with the fiber optic technology. This is becoming incredibly common in a lot of applications out there. Thank you again. I see a couple of requests for the deck in the question section. We will make sure we get that out to everybody. Again, thanks. Have a great rest of your day. Take care.